we're back. Okay, Mara wants to come in. Morning, Maru. Thank you for not bringing any chipmunks in the house. Yes, thank you. Okay, so, in the numerator, there are 720 different ways to get all 6 dice to come out differently. If you think of these as slots or the dice that as they roll come out, the first one could be any number for this to work. The second one can be 5 different numbers. The third one, 4, 3, 2, 1. So that's 6 factorial, which is 720. That's the number of outcomes that would make all the dice different. And then the total number of outcomes is just the probability of the dice. So 6 times 6 times 6 times 6, all the possible probabilities. So 720 divided by that 46,656 is this 2%. He didn't show that here. So the flip that, the 98% is the chance of all the dice having at least 2 of the same number. And this is where it got really funny. So some miscommunication while we were all at dinner. Then Daichi or Yoko thought maybe the real question was how the chances of getting 2 3s or more in the die. And so I think Daichi or someone said, well, just divide the 98% by 6. And then we thought, all kind of tried to calculate it. We came up with different results, but then Kai explained that doesn't work because you can have a situation where you roll 2 3s and 2 6s, and so now this is an outcome that's part of getting 2 3s, but it's also an outcome of part of getting 2 6s. So the probability, so this actually satisfies both. So there's an overlap in those scenarios, and this is where Kai started to work through using slots. So this is his, I don't know if you can see it, but it's not necessary to see everything he did, but he built this slot set, right? And then he started to do these fancy things, right? So I'm going to try to explain how he did this. So I mapped it out kind of bigger in steps here. So the first thing he explained is he said, if you have 2 3s, you want to look at them in like lanes or sets, like lanes, I think he calls it, or slots, like a slot machine. And the 3s, if you have 2 3s or more, we'll start with the 2 3s example. You can start with them in these possible positions. So this is what's called the first set, when the first die is 3, and you get these 5 combinations. The second set is when the 3 shows up in the second lane, the second slot. The third set, the fourth set, and the fifth. Oh, whoops. That's me. I got it counted up and counted down. We have 2 first sets and 2 second. Anyway, there's 15 total slots. And then he went on to explain that every other slot, the probabilities is just 6 different probabilities, and you don't care because it's 2 or more. So you could say 6 different probabilities of them. But he said the flaw with that is it's also an overlap scenario, because you want to rule out where it's 2 3s and 2 6s. So there's certain scenarios where you're constrained. You don't want in identifying the 2 3s or more to double count. So he came up with this concept, which is in the first scenario, if the 2 3s are here, these are 6 different possible outcomes. When it's here, this one is only 5 different possible outcomes, because you definitely don't want to see the 3 again. And these are not constrained. And this one, likewise, you don't want to see the 3 again. You don't want to see the 3 again here, and these are not constrained, and so forth. And so there's these probability sets that go like this. There's the first set that I showing pictorially. The second set is just 5 to the 4th forever. So So in the first channel, we've already done all of them, so they're already flipped to 5s. Here's now the 3 is showing up in the second channel and the third channel, and then these are 5s, and now that gets knocked down. So those are all always 5s. The third set, all 5s, but you're repeating the pattern. The fourth set and the fifth set. So that's the total 15 patterns. And so now the math on the first set about how those probabilities are is it's 6 to the 4th different ways to get this result of two threes in the first 2 positions. So it's 6 to the 4th. The second one is 6 to the 3rd times 5 to the 1st. 5 raised to the first power. So 5 raised to the first power, 6 cubed, etc. on down. So then you just add up all these outcomes, the number of outcomes you get in that first set, 4,651. And then the remaining sets, it's always 5 to the 4th power. It's always 5 raised to the 4th power. So you add, and there turns out to be 10 more of those, because remember we had 15 slots. The first 5 are tricky, and the remaining 10 are very similar in terms of number of possible combinations. And so that's down here. So that's 4,651 I took from the first set of possible results, and 10 times 5 to the 4th, which gets you to 10,901. We know what our total possible dice sets are. We now know what our total possible scenarios are for 2 3s or more, having ruled out any overlaps. And so the actual answer is 23.4%. And that's Chi. So I thought that was pretty cool. That wasn't the original question, turns out. But he solved it.